Thank you all for an excellent presentations from Rajesh, Vivek, and Stephen. Can we have one round of applause? That's good. I'm happy to, before I start any questions and open it for delicate Q&A, I just want to make an announcement. Post lunch, we have sessions going in both the tracks here as well as in Conclave. As I mentioned in the morning, we also have a roadshow in the smart booth. So please keep that in mind. So choose your options, what you feel is the best. So let me start off possibly one or couple of questions from my side to each one of the speakers. Just give me a second. I just want to ask one question to Rajesh. Many organizations have successfully piloted AI but struggle to scale. What does it make to move from AI experimentation to autonomous industrial operations?
Yeah, thanks. As we just saw that pilot is relatively easy because you are talking about a specific use case and you're able to possibly find a way to get the data that you needed. You could even do simplified way of even manually doing the contextualization of what that specific data belongs to, because just getting a tag from an operational tag and making anything decision out of that is not going to help, right? You're not going to make a trusted model decision based on just looking at a simple data. And it needs an information, it needs a context. So what we are seeing is the moment people do the pilots, the way they want to scale it, whether it could be for scaling for different kind of an assets predictive models, or you want to do a process optimization models, you would like to do even energy optimization models or predictions. First and foremost is the contextualized data. We call it the contextualized foundation. It is pretty much about once you get the data integrated from different systems, how do you make the information to understand each other so that the knowledge layer we call. And it has also gone through the different value evaluation of like what is context means. Today, the output of input of the contextualization you can consider is to greater extent a curated data. You possibly do a data quality, data governance. The output of the contextualization is what we call as an industry knowledge graph, which is fundamentally, you use the Google map today able to navigate across different aspects. You could bring the knowledge graph to make it anybody to consume easier. So people who are able to mature has been able to, knowledge on contextualization has been able to scale. But again, quick question is, it's not that we have to solve the entire world's problem. You can take a specific use case, a set of use cases, and trying to look at whether you are data ready or to be able to make it contextualize and make it scale. I've seen the organizations where successful of getting the autonomous operation is that taking a specific use case, then scale it for either multiple units or even multiple sites and so on, rather than take like top 25 use cases and try to actually implement in one particular site and you try to fail. So it's better to take and make an impact across.
Thanks, Rajesh. I'll just have one question to Vivek. It was quite interesting to listen to OT integration at this stage of AI. So it was extremely good to refresh myself. So in your presentation, you mentioned that IT/OT integration must be use case focused and not technology focused. Can you please give us some real life some examples?
Great question. So let me take it from where Rajesh left. So the previous question was AI, there are a lot of pilots of AI happening and scaling is a challenge, etc. So this dovetails to also this question, because I can tell you that I'll give you an example. Um, in my presentation, I spoke about the data integration layer where you could have the data contextualization, the connectors, and then on top of that AI for inferencing, etc. One use case that I can put forth on the table is inspection, yeah, for quality, traceability. Now, typically inspection systems have camera, then you have the server where you capture the inputs from the camera, then there is an engineer who works on the images, etc., cleans it up, etc., and then there's an operator who continuously runs the whole show. Now with the architecture that I showed you, you don't need this at all. You just need to take 20 images, give it to the AI inferencing server, and that's it. Rest everything is done. So there's a camera, there's a lighting system, certainly there's an AI running on top, and you can get the vision system running in 5 minutes. Yeah, and you don't need to have somebody to go through the images, etc., and everything, take the clean ones, drop the not so clean ones, etc. So AI is helping our customers to achieve this. Now this is where, if things are simple, then they can be scaled, because you could take this model and apply it to electronics, you could take this model and apply it to CPG, you could take this model and apply it to pharma. This is what we mean by scalability coming in. Yeah.
Thanks, Vivek. Before I ask a question to Stephen, I just want to mention OPC was a savior during my days in BHL, connecting through RS-232, RS-485 in 2008-9. When OPC came into picture, it was a miracle for us in those days, because customers wanted interoperability, interconnectivity of information between BHL systems, Honeywell, ABB, Siemens, whatever you name. So OPC was the biggest eye opener for us, and then after OPC came into picture, life became quite comfortable for doing the interoperability. So a lot of plants in India, lots, maybe hundreds of plants in India use OPC and OPC now. So you can meet people and they'll tell you. So that's one feedback for you.
That's why I'm wondering, where's the success story to show it to the world?
OPC was the biggest savior for me in those days, okay, when I was working in BHL. I'll ask you a bad question, possibly. What is not optimal or weak in OPC UA?
Oh, well, that's a tough one. I believe from a technical point of view, we are really good, because I mentioned, having an ecosystem since 20 years, which never lost backward compatibility, is really fine. What I see is, I mentioned this just a little bit during my presentation, when I started 32 years ago, OPCUA it has been designed by IT and OT people, because it's a super strong IT standard. But mostly at the beginning, it has been implemented by OT people who had deep knowledge, they know what they do. We have been in different times where you had more time to really understand, dive deep into topics, and then understand first the big concept and then start implementing. And meanwhile, we have grown that much into the IT world, and you have seen that even in digital product passports, that specifically in the IT world, people believe if they get an easy solution, then this is the way they go. And so sometimes we are in discussions on, we are using different technology because it's easier and it's a simplified MQTT and so on. Why not go with this? And then our explanation is not really good. So we could do much better in education and explanation and finding information. This is, I believe, the biggest topic. Because there's a difference if you just let a student play around for a prototype, moving data to a cloud. This is a different story to let data flow one way, instead of having a full, robust industrial solution with a secure boot up, with a complete security environment, to have bidirectional information and so on. That's a different. And if you implement all this also to other easy, so-called easy standards, and you are exactly where OPC is today. So I believe the point is we need to have much easier ramp up for people who are not completely understanding the complete architecture of OPCUA. There's one example in the area of medical devices, measurement, analytic devices. They are organizing 3 times a year. So it's an industry called doing the LAD standard, Laboratory Analyzer Device Standard. They are running 3 hackathons per year, only for 2 days. And developers are coming and they have no idea what OPCOA means. They have never heard this term. But then they are grouped by the implementation language they are using. Here is a table where all the people using this SDK are. Here are all people sitting using the open.NET offerings. And then after the first day, they are able to load an information model. And the second day, they implement how to do the protocol to their own dedicated proprietary area. And after 2 days, they have a working, running prototype. And then they see, oh wow, and I can connect immediately to all SCADA systems, to all PLCs, to all cloud systems in the world in a secure way, audited by security agencies around the world. Cool. And this is what I want to see more, right? Super small implementation time, better education.
Thanks, Stephen. I'll open it for audience questions. We have about 12 minutes, so can please move the mic, every team.
Hello, sir.
Please introduce yourself
Yeah,
and then
my
be,
name
be,
is-
be brief in your question and tell whom you are addressing the question.
Yeah, sure, sir. So my name is Rohini Patil. I am from Reliance, working in a digital transformation team. So my question is to Rajesh, sir. So I want to know the success story from your one of the customer who is in oil gas manufacturing and who is using your GenX at scale and the most business outcome they have achieved through it.
Yeah, sure. So there's many. So across the industries, Genix is deployed, including the refineries, oil and gas, mining, as well as on the manufacturings of pulp and paper and chemicals and whatnot. The biggest value always across through this 3 dimension of efficiency, reliability, as well as on the sustainability side. I would call one of them, which I also mentioned about how it changed in the life of the people on the field operators. 80% of the time of the troubleshooting for a person on the shop floor has been reduced. That's a big value. More importantly, it also helps not only about your operational productivity, the empowering the person on the shop floor, saying that they bring the value high. And this can be implemented. I mentioned about close to about 80 different co-pilot agents which are there, number one. The second thing that I will talk about is how an operational efficiency is improved for mining operations. At the same time, the cognitive load of a person on the control room or digital operating room is changed. Just imagine that a person in the control room is looking at the alarms that are generated. You could still give assistive intelligence with a co-pilot, which I also mentioned about it, but still, to be honest, the AI there, assistive intelligence, is making you a bit more cognitive load sometimes. What's happening, you need to prompt. Imagine that the ask is, the person just want to be there in the room, but agents are helping them to be able to make an intelligent alarm analysis and tell only the ones they want to look at it. So this is not only making your safety, operational safety better, but also helping the human to become a lot more, I would say that, bring their health aspects better and reduce the cognitive load. If you have to talk purely in terms of the business impact, I would say that using the predictive maintenance, going beyond just a predictive maintenance for asset performance management, but covering also the aspects of not only looking at your AI ML on the data driven and fault modes, but also then taking the agents that are looking at operational reliability, process reliability, as well as asset performance together. We saw the savings of millions of dollars for critical assets, for instance, like gas turbines, just in a week of implementing a solution. So you can think about 3 areas: asset reliability and maintenance savings, operational efficiency along with helping the operators, and of course significant reduction on the energy and emission side to the degree of even 30% reduction we have seen on the energy side. So those are all clearly the business values. And of course I will be happy to talk to you on sharing more on what we can do along with, and of course Reliance is a big customer as well for us.
Sir,
Hope that answer your question.
I'm Shankar. I'm Shankar from National Aerospace Laboratories. What I wanted to, the question is, now we are integrating IT and OT, but as we are moving from Industry 4.0 to 5.0, the communication technologies become equally important where machines talk to each other and the entire ecosystem is talking, and the latency also is an important thing because there are so many IoT sensors, cloud, edge, everything working together. Is there a common platform we can design where everything is handled on one common platform, including IT, OT, CT, communication technologies like 5G, 6G?
Whom are you addressing?
I thought I reported about that.
Now
I think
at this
I can just state an example in my presentation, talked about the autonomous operation for the marine. It's clearly an example where, in fact, more than not only an IT, ET problem, it's about the CT problem as well, where actually the connectivity is very bad in many cases in the marine vessels go. So how do you solve that problem with bringing the CT along with an IT OT has been the challenge. We have Genix solves it in this case of ABB. There are companies that have solved this in the platform, and we use clearly the standards of OPC here to be able to ensure that what comes from the CT is also using the same information model.
That was exactly the key answer. It is not about the protocol. You talked about Wi-Fi 6 and so on. This is a transport. It is not for modeling something. So we need one agreement on model the data, and then it depends on the application. There's not one true architecture on keep all information in the cloud or keep all information in the edge. I don't believe on that story. Sometimes it's mission critical and you have to do it near at the process in real time, in deterministic real time. Sometimes you can run it in the cloud. But one small warning here. Whenever I talk to the cloud people, they have sometimes a little bit a different story behind. They also say, yeah, we need the data in one central point, and then they offer, put them all in my own cloud, and we have all the protocols, and we normalize the data in our cloud. And this is exactly where the OPC Foundation, and me personally, has a totally different understanding. We should normalize and standardize the data as near at the data source, because then all the layers in between can work on this. I'm not against cloud, don't misunderstand this. I'm just saying we should be independent from all these big cloud suppliers and tell them what standard we use and what standard we want. And that's why I'm happy about the cloud initiative. So my answer is clearly standardized data on OPCA. I see no competition. Is somebody here in the room seeing another modeling language which has relevance for the industrial automation market? Maybe I'm wrong.
I think we are running out of time. Yeah, so maybe I'll just add 2 cents to that. So it has to start from the use case. Depending on what use case are you trying to achieve, you go with all the models of the architecture, etc. So one bad news is beyond the automation layer, nothing is deterministic, right? We are not talking about determinism above the automation layer. Now, in the earlier times, as I spoke during my presentation, when cloud came in, everybody wanted to put the data on cloud. Today, they found out that in that architecture, the basic problem is, of course, the protocol layers. Even if you solve the protocol layer, latency becomes your biggest challenge. And of course, security, data privacy, etc. So it is better to go in for the edge option, because edge will allow you to harmonize the data layer, harmonize the integration of the data, and below the edge and above the edge, you can put the CT, that's your communication technologies that you wish. For example, like he mentioned that multiple communication technologies are available. Like you can go for Wi-Fi 6, you can go for Wi-Fi 8, you can go for 5G, you can go for wired systems, etc. So it really doesn't matter. So you want which use case to actually use that data and give the data back to the system. So this round trip, we call it, as you know, that we call it as a round trip of data. This determines what architecture you need to use. So we could talk more a little later.
Thank you. I think
I have
we're
one
running short of
question.
time.
Okay.
Maybe I'll take one question.
Okay, sure, cool, thanks.
Maybe you can interact during the breaks, okay?
Okay, one quick question. It takes off from what you asked to Stefan. My name is Sunil Shah. I run a company, Modelicon. So I'll continue with what Mr. Ganpati Raman asked about where OPC UA might not be optimal. How good is OPC UA for millisecond data? If I'm looking at vibration data, or I'm looking at AC signals, etc., where I want things in nanoseconds. My personal feeling was the information modeling makes it a bit too much on the there is too much of overload on that because of that. Yeah, cool. Thanks.
Well, I think you're addressing where does OPCUA start, at which level
Yes,
and
that's
what about real-time, millisecond, microsecond, and so on. Because I was just having 20 minutes speaking time, I focused on this cloud and keeping the data in a model and keep them up to cloud. I skipped the part talking about the field initiative of the OPC Foundation. This started 2018 with all the big companies, OT companies, including here Siemens, ABB, Yokogawa, and a lot of others are in the room. And meanwhile, and this initiative has two goals. The goal number one, the specifications are done, they are public since 1.5 years. It is about horizontal connectivity between assets in the factory floor. This is what I mentioned with transporting data via UDP in a quick way. Because when I exactly started 32 years ago, reading data from the Siemens PLC, by the way, converting it into another PLC and sending it down there, right? It was always with a connector. And to make this more efficient, quicker, by just configuration, we have this C2C, controller-to-controller communication. The group decided that certification is mandatory, and right now, status today, there is no device in the lab, but I'm expecting that this is coming soon, because there is no competition in the world, and everybody needs this, and everybody is aligned that this makes sense. The group has already started the second phase of the project. This is C2D, controller to device. There is specification work ongoing. They believe that they can finalize the specification in 2027. That would be fine. But predicting how long does it happen to have the release, to have an update, to prepare the certification lab and so on, I believe that we don't see products before 2030, honestly. And then OPCUA is, then we have to see, and this is why I can't talk about this, because if you talk with field bus people, they immediately talk about minimum cycle time, jitter, they talk about features like redundancy and so on. And this is what we can't talk about. I have no measurement, because even the specification is not done, on what is a cycle time, what is a jitter, and so on. Because of my knowledge, being 30 years in industry, I believe that OPCUA FX, the field exchange, is quicker successfully in the process industry. Because there we can tunnel via Ethernet APL and have really, we are getting down into the endpoint of the device. So we have an, I don't know, Anderson-Hauser device and all the other devices here running Ethernet APL, and you have OPCUA inside the device. You plug in the cable, the device gets booted up and is immediately providing data for process automation real time with information model and security to the world. That's unique.
Thanks, Stephen. I think...
yeah, with the other topics, it's too early to talk about this. Yeah, I can't tell you. I would love to tell you, but I can't.
I'm sorry, we cannot permit more questions. Already getting to the time, so you can have these interactions with the people. It'll be great to have such interaction. Before I conclude, I want to thank Rajesh, Vivek, and Stephen for making excellent presentations. And more than as much we value their presentation is their knowledge and competence and coolness in which they can take on questions. So that's simply amazing for me. So thank you again for their contribution.